All right, welcome to a short special video for operating systems class. At the end of our Wednesday lecture, we got right up to being able to look at an example using the Sockets API. We had just talked about the Sockets API for a C program that wanted to communicate using TCP. And we also talked about UDP. But we hadn't looked at the example yet. So I wanted to quickly go through that example, look at the code, hopefully quickly, and then give it a try before we're done. What this example does is it comes in two pieces, like any program using TCP. One piece is going to have to be the server. It's going to open a socket and then listen for connections. The other one is going to be the client. It'll make a socket and then try to connect to that server. And then we'll push a megabyte of data from the client, from the client end, from the sending end to the server end to the receiving end. And we'll try to push it 64 kilobytes at a time. And we can see how long it takes to get there. And we can watch what happens as it travels a little bit, as it travels from client to server. So to show off this program, I've got two windows. One of them is going to do the sending. One of them is going to run the receiver. Here, I'm logged into a machine. I used to teach at Baylor University in Texas for about 15 years, and I've still got an account on one of the systems there. So talking to this system, we're talking between two machines that are probably close to 1,000 miles apart from each other. Here, I'm logged into that machine at Baylor, and I already copied the source code that we're going to use up to this machine. So let's take a look at it. The server is a program. This should be posted on our website, our Moodle site also. So if you want to give this a try yourself, or if you want to run it as I'm showing it, that should work also. You'll have to compile it. But the TCP receiver, TCP recv.c, is the server end. This is the one that makes a server socket and then listens for connections on that. And it's using the same socket API that we just talked about. Down here is where it makes the socket. So we said there's a system call socket. You give it some parameters, and that helps decide, or that determines what type of socket you can that you're asking for. You can see for these three parameters, instead of filling in my own values, I use this getAddrInfo call. Normally we might use this to, given a host name, resolve that to an IP address, but I can also use this to figure out the parameters for the kind of socket I want. Before I call getAddrInfo, I prepare this addrInfo struct. I fill its fields in with the things that I want. For instance, you can see here, I want to make a socket that can talk over TCP. And then when I call getAddrInfo, it gives me a list of addresses that I can use, or addrInfo objects that I can use for talking using the parameters that I specified up here. If this call is successful, like I said, it gives you a list of addrInfo structs. I just use the first thing on that list, and I use it to get the parameters to socket. So this should give me a server socket, one that I can listen for client connections on. We said if you're the server, there are a couple of calls that you can make, that you have to make before you start accepting connections. And that's what I do next. We said you have to bind the socket to an address. So I make a call to bind. You have to tell it to start listening for connections. So that's what I do here. You have to tell it to accept a connection. So normally, if you're a typical server, this might be inside a loop. You would accept a connection from a client, and then you'd accept a connection from the next client. So whoever wanted to talk with you, you would just accept clients one after another. And we said when you call accept, it'll block until a client tries to connect, and it'll give you back a socket that you can use to actually talk to that client. And that's what the return value of this is. We said that the socket you get back will be something you can use just like a file descriptor. And sure enough, I can store this in an integer just like I would for a regular file descriptor. So, oh, and I should say, A normal server might accept client after client as long as they want to connect, but this one's just going to talk to one client. It's going to connect to that client. It'll count on receiving a megabyte of data from the client, and then it'll quit. So it won't do what a server normally does, accept clients over and over until we terminate it. So I've got my connection from the client. I'm going to receive data from the client until I have a megabyte. And that's what this loop is doing. Until I've received about 1 million bytes of data, I'll compute how many bytes I have left up to the size of my buffer. And I think my size of my buffer, like we said, is 64K up here. So I've got room for 64K. If I'm getting near the end of the megabyte, I won't try to read 64K because there may not be that much left. So here I'm figuring out how much I want to receive in the next call to read. And then I call read, the same old system call you would use to read from a file, except I give it the socket I got back from accept. I give it the buffer I want to read into, and then I tell it how many bytes I have room for. And it'll read as much as it can, either until it hits this limit or until it's read everything that's available right now. The data is going to take a little while to get from client to server. So the first time I call read, it may not all be there. This will block until at least some more data is available for me to read. I print out a message saying how much I successfully read. I count how many bytes are read, and then I go back around the loop. So this should keep looping until I get a whole megabyte worth of data. And then the server's pretty much done. It closes the socket I was using to talk to the client. And that server socket we were using to listen for client connections, it closes that. Both of these just using the plain old close system call we learned about early this semester. And then the server's done. We just exit. This is already compiled and ready to run. But before we run it, let's take a look at the client side. This is the one that's going to connect to the server, and it's going to try to push a megabyte of data across a TCP connection to that server. This is TCP send. It's a little bit shorter because it doesn't have to bind the socket. It doesn't have to accept connections. So down here in main, here I'm also going to use attr_info, but I'm going to get a little bit more work out of it because I also need to resolve an address. As a command line argument, you can see the usage message up here. We're expecting to run TCP send, and we're going to give the host that the server is running on as a command line argument. That's going to be, we're going to type that in as a host name and a domain, but to actually talk to that system, we need to turn that into an IP address. So you can see when we call get attr_info, the first argument we pass into it is the host name given on the command line. And then the rest of the arguments are either this attr criteria up here, the parameters that we want it to consider when it's trying to decide how we can talk to that server. And I think I forgot to say this in the other program. A port number for talking to the server. This is or for connecting to the server. This is the port number that I expect the server to be listening on. And when I try to convert this to a attr_info structure, I fill in that port number. The port number, you can see it's a preprocessor constant here, and I've got a header file that defines that so that both the client and the server can easily use the same port number, as long as they're compiled with that same header file. So if this is successful, same here, it might give me a list of attr_infos. I just use the first thing on that list, and I call socket using parameters that I just got from get attr_info. If this is successful, then I get back a socket, which here on the client side, this also looks like a file descriptor. If I want to write data to the server, all I have to do is use the system call write and send some bytes to this socket. Ooh, I forgot to talk about this, but just making the socket doesn't automatically try to connect. When you want to try to connect to the server, you have to call connect on the client side, and then this will block until a connection is established. So after you call this, your operating system and the operating system on the server side we'll do that 3-message exchange to try to establish a connection. If this is successful, if it's not successful, I bail out right here. So if we get down to here, it must have been successful. And I'm going to send blocks of data to the server. Same here, up to 64 bytes at a time. This is almost the same loop we had on the server. Until I've sent a megabyte of data, I'll figure out how much I need to try to send. That's either size of the buffer or however much is left in the megabyte that I'm trying to send. And then I make the same write system call we would make if we were trying to write to a file. I tell it to send whatever's in this buffer, however many bytes I want to send, and this is typically going to be 64 kilobytes until we get to the end, and send it over that socket that I made up at the top of this program. Same here, we print out a report every time we successfully send something, so we can kind of see the blocks that are getting sent as this program runs. We count what got sent, and then we go back to the top of the loop. And then once we've sent that megabyte of data, we're done. So the client closes its socket. That's all it has to do. It never had to make a server socket. As the client here, we're counting on connecting to a server that's already running. So I just have one thing to close here, and then the client can exit. So we've seen the code. I've already compiled it. So here on this system, the system at Baylor, I'm going to run the receiver, the one that does the job of the server, TCP receive. All right, and now I didn't get any error messages. So I'm going to say this successfully called getAtterInfo. It called socket to make a server socket. It called bind on that. It called listen. And now it's blocked in a call to accept. It's sitting there waiting for a client to accept. Down here, this terminal window, the smaller one, is just running on my laptop right here. So it's running here in North Carolina. I'm going to run the other end, TCP send. And then when I run this, the client will call socket to make a socket. We already saw it'll call connect to try to connect to the server. And if that's successful, it'll start trying to push a megabyte of data over to the server, up to 64 kilobytes at a time. And when I run this, if you watch, since they all report messages every time they receive a little bit of data and every time they send a little bit of data in the bottom, we can watch how this gets transmitted. Oops, I forgot. We have to, the client program, the sender is expecting a host name on the command line. And we're running on a system eos.baylor, sorry, ECS, it's been a while, .baylor.edu. And now when I punch send, you can see a bunch of messages scroll by. You can see when the client, when the sender sent, well, every time we could scroll back and check, but it looks like every time it tried to do a send, it was successfully able to at least write out 64 kilobytes of data. But up here on the receiver, we didn't get the data in those same units. I often say we didn't get it in the same gulps worth of data. We still got all the same bytes. I don't have any code to check this, but we could easily add code to make sure that exactly the same sequence of bytes that get sent is what gets received. But you can see when the server called read, sometimes it got 1448 bytes. Up here, it got 27,512 bytes, and a kind of a biggish gulp at the end. And this is kind of what I mean when I said TCP doesn't respect message boundaries. When you try to do a read from a socket, if there's nothing available, you'll just block until something arrives. If there is something available, if there's some data that's been received by the operating system, it'll give you as much data as it can up to your buffer size. But if that's not a whole message, you're going to have to call read again to get some additional bytes of data. So in TCP, since it doesn't respect message boundaries, you have to do that yourself in an application, just like if you were communicating over a socket. You might do this by putting in some kind of message delimiter. If you were sending text data over a TCP connection, you could have every message be a line of text, and then the new line character could be your message delimiter. You could prefix every message with a size. You could write out an integer worth of data to say, here's how big this message is, and then that many bytes could follow it. But that's something that you have to do within the application. TCP, as provided by the operating system, doesn't do that for you, whereas UDP does. Or at least if you send out a datagram in UDP, the receiver may not actually get that datagram if it gets if it has to get discarded, typically because of congestion. But if you get it, you'll get that whole datagram exactly as it was sent. I know I'm just recording this lecture, so I know no one can have any questions, but hopefully this makes sense, and hopefully this, the code, which should be posted on the website, along with working through this example, will set you up well to do the other part, the network communication part of your current homework assignment. So I'm going to go ahead and stop recording. Thanks for your attention. Have a good weekend. I'll see you next week.